As promised, I am back with another episode of Ratio. Let me introduce myself with my new friend. Hello, I am Lewis. Welcome to Learnzable. Today we will learn some more concepts helpful in solving problems related to ratio. Splitting ratios. Bob and Ron are two friends. They need to share $36 in the ratio 2:7. How will they do it? How many parts are in the ratio? 2 plus 7 is equal to 9, total 9 parts. So, what is 1 part worth? 36 divided by 9 is equal to 4. Let's multiply up ratio. 2 into 4 to 7 into 4 equals 8 to 28. So, Bob will get $8 and Ron will get $28. You can check if it is right or not. Just add together to check. $8 plus $28 equals $36. Perfect. Constant part. Constant part refers to the part that remained the same while the other part got changed. In this case, you will need to make the part which remained the same to be equal to each other. Seems confusing? Do not worry, let me show you an example. Ollie have red and blue balls in the ratio of 5:6. He lost 16 blue balls, the ratio became 3:2. How many blue balls did Ollie have now? Since only blue ball was lost, red balls remain the same. Red balls to blue balls is 5:6. Initial ratio. After Ollie lost 16 blue balls, red balls to blue balls become 3:2. Final ratio. Here red balls are the constant part, so we need to equalize both initial and final ratio terms of red balls. Thus, finding LCM of 5 and 3, which is 15. Now after multiplying initial ratio with 3 and final ratio with 5. Initial ratio becomes 15 to 18 and final ratio becomes 15 to 10. Now let the unit of ball be U. Thus, lost blue balls equals 18U minus 10U equals 8U. But we know 16 blue balls were lost. So 8U equals 16. Or 1U equals 2. Therefore, left blue balls equals 10U. Equals 10 into 2. Equals 20. Ollie has 20 blue balls now. Constant total. Constant total means the total remained the same. Usually, this concept applies to questions related to internal transfer. If a transfers an amount to B, A will decrease, while B will increase by the same amount. So, the total will stay the same. Let me show you an example. Ollie and Billy have money in the ratio of 5:4. After Ollie gave Billy $20, they had an equal amount of money. How much money does Billy have in the end? Since Ollie gave money to Billy, their total amount remained the same. Before. Ollie's money to Billy's money to total equals 5 to 4 to 9. Initial ratio. After Ollie gave Billy $20, they had an equal amount of money. Thus, the ratio becomes like this. Ollie's money to Billy's money to total equals 1 to 1 to 2. Final ratio. Now, to make the total term equal in both cases, let's follow the same steps, like previous example. LCM of only the total term from both ratios, 9 and 2, gives 18. Let's multiplying initial ratio with 2 and final ratio with 9. So, initial ratio becomes equals 10 to 8 to 18. And final ratio becomes equals 9 to 9 to 18. Since 1 unit amounts to $20, 9 units equals $180. So, now Billy has $180. Constant difference. Constant difference means the difference remains the same. Usually, this concept applies to questions related to age. As years go by, the age difference between two people will always be the same, because both will grow old together. The ages of Ollie and Billy are in the ratio of 4:7. In 3 years' time, their ages will be in the ratio of 3:5. How old is Billy now? Since Ollie and Billy grow old together, their age difference remains the same. Before. Ali's age to Billy's age to age difference equals 4 to 7 to 3. Initial ratio. After 3 years, Ali's age to Billy's age to age difference equals 3 to 5 to 2. Final ratio. Let's make the ratio equal, following the same steps, like previous examples. Multiply initial ratio by 2 and final ratio by 3. Equals 8 to 14 to 6. Equals 9 to 15 to 6. Therefore, 1 unit equals 3 years. 14 units equals 42 years old. So, Billy is now 42 years old. What a fun ride it was! We learned so many new things about ratio. See you in our next class.